All right, class, so this is an ALEKS topic that's called adding or subtracting and multiplying or dividing measurements. And this is one of those problems where we really do need to worry about sig figs. The point of this topic is to get us to learn and understand how to properly figure out the number of sig figs for a given problem when we're working in lab. So for instance, in this case, we have a graduated cylinder. We're going to weigh out some potassium chloride into that graduated cylinder, and we're going to be able to figure out, based off of those values, what mass of potassium chloride we put into the graduated cylinder, and then we're going to make a solution. We're going to add water such that our total volume is 172.73 milliliters. And then what it's asking us to figure out is the grams per milliliter for that solution. How many grams of potassium chloride are in every milliliter of our solution? We would assume that it's a homogeneous mixture, but let's go ahead and do this. And then of course, obviously we want to figure out what the correct number of sig figs are. So in this problem, the first thing that I would do is probably just draw a little picture. So I'm a big fan of these little silly drawings. So this is my graduated cylinder. It weighs 4.2 grams, and then we're going to add the potassium chloride, and it's going to go up to 72.923 grams. So the difference between these two numbers, maybe we'll write add KCl. The difference between these two numbers is going to be the mass of the actual KCl that we added into there, right? So we're going to add that KCl into our graduated cylinder. So if I take 72.923 and I subtract that and I subtract 4.2, 72.923 grams minus 4.2 grams is going to equal 68.723 grams. Now, here we need to figure out the correct number of sig figs. So every time we're going to do a calculation, here we're subtracting, we need to consider, well, how many sig figs should that number have? So this number here, I'm actually going to round to 68.7 grams. And the reason I'm doing that is because this 4.2 only has one decimal place. This number here, 72.923, has a lot of decimal places, but this one here only has one decimal place. So in my final answer for this question, I should only have one decimal place. Now I can see that this number here has 3 sig figs. If I want to sort of count, this has 5 sig figs. This has 2 sig figs, but when I subtract, I need to follow those decimal point rules. My answer is going to end up with, in this case, 3 sig figs. Now, I want to then divide this by our number of milliliters. So if I take 68.7 and I divide that by 172.73 milliliters, that should get me my final answer, 0.398 grams per milliliter. And again, I'm going to have 3 sig figs in my answer because this number here should have 3 sig figs. Now, you might, and I think some people would put this number, 68.723 grams, into this calculation, just keeping in mind that we want to round to 3 sig figs, and that's totally fine. That actually might even be better to do it that way, but just know that if you're using this 68.723 and you're dividing it by 172.73, don't think, oh, well, that should be 5 sig figs, right? Because this number really technically should only have 3 sig figs. So this calculation here, we've got 3 sig figs, we've got 5 sig figs, but we're doing multiplication and division. We're limited to the number of sig figs in our starting numbers. So this should only have 3. So my final answer should only have 3. So these problems are a little bit on the tricky side. Definitely, think about, well, what are the rules when I'm adding? What are the rules when I'm multiplying or dividing? And which one, what am I doing first, right? So since I'm doing this calculation first, I need to keep in mind, well, my answer should only have 3 sig figs because, again, I'm limited by that decimal place. But then once we get here, we're limited to the number of sig figs, which is 3. 68.7 has 3 sig figs, so our final answer should be this here. All right, hope that helps.